Hello guys, so now we are on to Unit 3, which is all about ratios and proportions and rates. Okay, and our first section is 3-1, ratios. So our essential questions today are, what does a ratio represent? And how can I use ratios to evaluate real world situations? You actually will hear these in the real world a lot. So comparing boys to girls, college graduates to non-college graduates, people who drive versus people who don't. Lots of things in the news that are actually ratios and comparisons of two things. Okay. So let's do some vocabulary first. Okay. So all a ratio does is show the relationship between two different relationship between two values. Okay. A rate is similar to a ratio, but it shows an amount of one versus an amount of the other. So the amount of one, let me actually reword that a little bit. The amount per another amount. So you can say the number of girls per class, the number of people per family, right? So those are all showing just a relationship of the amounts of one thing versus another. We'll talk about that in a minute, okay? Proportion are just two ratios that are of equivalent value. You guys have actually done quite a bit of this already. So we've done equivalent fractions. When you were tripling or cutting in half your recipes for your recipe project, that was all working on proportions, okay? They're equivalent value. Equivalent fractions are the easiest thing to think of, okay? So let's go over here. So a ratio shows the relative size of two or more values. Ratios can be shown different ways. So sometimes you'll see them written like this, where you have, okay, say you have 3 to 5. So what that means is if you have 3 to 5 boys versus girls, what that would mean is that if you had, in a group, you had 3 boys to 5 girls, okay? That would mean that you have 8 total, okay? They can also be written as a fraction, but typically when you're going to see ratios in a fraction, they are going to be talking about the total number. Oops, that's not your highlighter. Go back. Okay. Oh my gosh. Get it together, Miss V. Okay. So, usually by the total. Like we've talked about fractions, right? You always have the part and the whole. Okay. So one thing you're going to see and we're going to work with a lot is called a ratio table. So all ratio tables have a rule and they have an input and an output. So I want you to think of ratio tables like a machine, okay? And we're putting this into this machine. So in the top row, you're going to have your input, what you put into the machine. Let me make this a little better. I'm struggling with the pen today, guys. Sorry about that. Okay. So let's do this. So you have your input. Ooh, that's better. Okay. What you're going to put into the machine and then what you get out of the machine. Okay. So into my machine, if I put in a 3, I get out a 9. If I put in a 4, I get out a 12. So I want you to think about what's going on in this table just between those two things. Okay. So between 3 and 4, I added 1, right? I increased by 1. But in my output, if I added an extra 1 from 9 to 12, I got 3 more out. Okay? So just think about that for a sec. Now I want you to think about what you would get out if you put in a 5, a 7, and what number do you think would go in between there? So think about that for a minute. See if you can figure out the rule and figure out what's going on, and then come back and check. Okay, so logically, I would have a 6 in between the 5 and the 7, right? And if my rule is that I'm adding 3 every time I increase this by 1, then 12 increased by 3 would be 15. 15 increased by 3 would be 18. And because these are still all increasing by 1, and then 18 increased by 3 would be 21. Okay. Now I want you to think about if I put a 24 in here as an output, what number would I have had to put into the machine using that same rule to get out a 24? Well, that number would be an 8 because I'm still increasing by 1. So think about what the rule is for this. Okay. And the rule is that you are multiplying by 3. In a ratio table, you can determine the rule always by dividing your output by your input. And in a ratio table, that answer has to be the same every time. So 9 divided by 3 equals 3. 12 divided by 4 equals 3. 18 divided by 6 equals 3. So as long as I'm getting the same ratio every time, I have a correct ratio table. Okay, that's notes. Super quick, super easy.